Hi everybody, how are you? I hope you are fine. Today we are going to take some examples and exercises on how to plot the points on the coordinates x and y. Here we have an exercise on the square net shown. You have to plot the points A, B, C, D, E and F. Number 1, we have A, B, C, D, E, and F, and we have to plot their points on coordinates X and Y. First of all, I have to draw the X coordinate. As we said before, the X coordinate starting from 0 to the infinity. And we have to draw it on a horizontal line. And the Y coordinate, we have to start from the same point of starting the X coordinate, which is 0, and upward, moving upward to the infinity. So this is the Y axis. Then each one unit will be a number, will be number 1, 2, 3, 4 to infinity. Okay, let's start to plot the points. We have number 1 has the points 9 and 4. How can you record it on the X and Y axis? You have to start from the X number. Now, the first number is the number of X axis, and the second number between brackets is the Y axis. We have 9 and 4, so we have to start from 0, moving 9 units forward, and 1, 2, 3, 4, 5, 6, 7, 8, 9. Then starting to move upward 4 points, then plot the point. So this is the point A. B, we have 0 and 6. So I have to start from recording and moving on the x-axis for a 0 step or 0 point. So I will stand on the 0 point and moving how many units upward? 6 points. Yes, I will move 6 points upwards, then stop and plot the point B. So this will be the point B, 0 and 6. The point C, we have it 2 and 4. So I will start from 0 digit on the x-axis. On the x-axis, I will move 2 units forward, then moving upward for 4 units or 4 steps, then plot the point C. We have the point D, 2 and 9. I will move 2 points forward or 2 steps and move upward for 9 steps, then plot the point D. We have E, 7 and 7. So I will, starting from the point 0, I will move 7 steps forward on the x-axis, then going upward for a 7 steps and stop, plotting the point E. The last point, which is F, I will plot it by 0 and 8. So I will start from the point 0, moving upward for 8 steps or 8 points, then plot the point F. Second one, we have also A, B, C, D, E, and F, but with a different numbers, So I have A here, we have it 7 and 8. So I will move 7 steps for x-axis, then moving upward on the y-axis by 8 steps upward, then plot the point A. We have B, 7 and 2, so I will start moving 7 steps forward, then upward on the y-axis 2, then I will stop and plot the point B. We have C, 5 and 2. I will move forward 5 steps and moving upward 2 steps, then plot the point C. Then we have D, 9 and 2. I will move forward on the x-axis for 9 steps and upward for 2 steps and stop, recording the point D. E, I have it 4 and 5, so I will move 4 steps forward and 5 steps upward. Then plot the point E. The last one, F, we have 3 and 7. So I will move 3 points forward and 7 steps upward, plotting the point F. You have to note that in the coordinate 1, we have points like B, 0 and 6, and F, 0 and 8. The x component is 0. That means that these 2 points located on the y-axis only. So this means that if I have the x component 0, so the point of having a 0 point on the x component, this means that it will only located on the y-axis. Otherwise, if we have point 0 on the y component, so the point will only located on the x-axis. Second slide, we have also a figure shown, and he wants you to write the coordinates of the points P and Q. The numbers of P and Q are given in the example or in the exercise here, and you just have to plot it on the y and x axis. We have point P, 3 and 2. How can you record it on the figure shown? You have to start from point 0, as we said before, moving. For the x component, you will move on the x-axis for 3 units forward or 3 steps, and upward for 2 steps or 2 units. Then stop and plot the point B. Then you have point Q. How can you record it? By the same way. 1 is the x component and 5 is the y component. So I will move 1 step starting from 0 point on the x-axis and 5 steps upward for the y-axis, then plot the point Q. Next exercise, plot the following points on the given lattice. We have A, 3 and 0, B, 6 and 0, C, 6 and 4, then complete the following. First of all, I have to draw x-axis on a horizontal line and y-axis on a vertical line, then start to record the points A, B, and C. Then he will ask you some questions about the shape will be shown on the figure. Point A, when I record it on the x-axis, it will be 3 and 0, so I'll move 3 steps forward and 0 steps upward, then plot the point A. You have B, 6 and 0 by the same way, and C, 6 and 4 also by the same way of recording the points on the lattice. Then complete the following. Here we have, by matching the 3 points by each others, you will get a triangle ABC. Number E, he asks you to find the type of the triangle of ABC. As shown in the figure, it's a right angle triangle. So it's a right angle triangle. And number B, he asks you to find the length of AB. I told you before that each one square on the lattice is considered to be a 1 unit length. Is considered to be a 1 unit length. So AB, if I stop on the point A and moving till point B, you will find yourself that you are moving 1, 2, 3 points from A to B. So the length of AB will be 3 unit length. What about BC? If you start stopping on B point and moving upward to go to C point, you will find that you are moving 4 unit length. Okay, number C, what's the area of the triangle ABC? First of all, we know the rule of the area of the triangle, which is half times base times height. Here we have the base, 3 unit length, and the height, 6 unit length. So it will be half times 3 times 4 equals 6 area units. Okay, here we have another type of exercises that he is asking me to find without drawing or without plotting the points on the lattice. He asked me to find the coordinate of midpoint between two given points on the exercise as shown. If we have number 1, we have A 3 and 6 and B 7 and 6. Then the coordinate of midpoint A and B are what? How can you get it? How can you get the midpoint between 2 points without drawing? I told you before that the first number between these 2 brackets is the number of x components and the other number is the y component. So if I want to have the midpoint between 2 points, I will take the x component here plus the x component on the other point, then divide them by 2. I will get the midpoint. As you see in number 1, we have A 3 and 6, B 7 and 6. How can you find the midpoint AB? First of all, for the x component, here we have 3 and 7. How can you get the midpoint? I will add x component here plus x component here divided by 2. So it will be 3 plus 7 equals 10 divided by 2, it will be 5. What about y component? I will take also here y plus y divided by 2. So it will be 6 plus 6 equals 12 divided by 2, it will be 6. Number 2, I have x 6 and 4 and y 10 and 4. Then the coordinate of midpoint x and y are what? By the same way, for x component, I will take 6 plus 10 divided by 2. I will get it 8. For y component, 4 plus 4 equals 8 divided by 2. It will be 4, the same number. Number 3, if C 0 and 5 and D 4 and 5, so the midpoint CD are what? By the same way, for x component, 0 plus 4 divided by 2, I will get it 2, and y component 5 plus 5 equals 10 divided by 2, it will be 5. You can get 4, 5 and 6 by the same way. Number 4, we have A 1 and 3 and B 3 plus 3. So the midpoints for x component 1 plus 3 divided by 2, I will get it 2, and 3 plus 3 divided by 2, I will get it 3 as it is. 5, 4 and 2, x and y 6 and 4. So the midpoint x, y are, for the x component, 4 plus 6 divided by 2, I will get it 5, and 2 plus 4 divided by 2, I will get it 3. The last one, number 6, and you can do it also by yourself, it's very easy. I just say to you to check your answers, but please do it before you listen my answer. If x 8 and 3 and y 0 and 9, so the coordinate of midpoint x and y are what? For the x component, 8 plus 0 divided by 2, it will be 4. For the y component, 3 plus 9 equals 12 divided by 2, it will be 6. That's all for this slide. Here we have on this slide another exercise and some points, and we have to record them on the lattice shown. Then answer the questions shown in the exercise. Okay, number G, we have number E. You have to record the point G by the same way we did it before, 2 and 1, and moving to two units on the x coordinate and 1 unit on the y coordinate. Then stop recording the point G. Then F 6 and 1 by the same way, then E 2 and 3 by the same way, then match the 3 points by each others, so you will get a triangle EFG. He's asking some questions about this triangle. He wants to know the unit length of GF. How can you get it? You will stop on G and See how can you go to the point F. You will move how many steps or how many units? 1, 2, 3, 4. So this is the unit length of GF. We have EG. By the same way, you will start on E and moving how many units to go to G. You will find you will move only 2 steps or only 2 units on the lattice. Number F, the area of the triangle EGF. By the rule, of course, first you have to write the rule, half times base times height. And you have the base 4 unit length and the height 2 unit length. So you will write half times 4 times 2 equals to 4 area unit, not unit length, because we are recording now the area, not the length. So the unit will be an area unit. Just you have to know that the points E and G are on the same vertical line E, opposite to 3 and G opposite to 1. So the length of EG will be what? Will be 3 minus 1 equals 2 unit length. Also, points G and F are on the same horizontal line, which is G opposite to 2 and F opposite to 6. So the length of GF will be 6 minus 2 equals 4 unit length. Okay, here we have a new lesson, which is reflection. What's reflection? Reflection means if I have a shape drawn on the lattice figure and I want to know the reflection of each point on this figure. How can I know this? First of all, I have to draw a line of reflection. I have to draw a line of reflection between the shape I have, the original shape, and the reflection of this original shape. So I have to draw between them a line which is called a line of reflection, as shown in the figure. The line L, it's a vertical line, and this called a line of reflection. Okay, if I have a parallelogram as shown on the figure A, B, C, D, and I want to know or to find the reflection point of each point on this parallelogram. First of all, I have to know the distance between the point and the reflection line L. So the same number of units I will move or I have it from the point to the line of reflection must be equal to the number or the distance between the point of reflection and the reflection point on the other side. What does it mean? If I have, as shown on the figure, A, B, C, D, and I will draw the line of reflection, which is L, then the distance between A and L is how many units? Is only 1 unit. So I have to draw A dash to have the same distance between the line of reflection to the A dash. So I will move only 1 step or 1 unit to have it 3 and 4. So if A is 5 and 4, so I will move on the other side only 1 unit to have A dash 3 and 4. Okay, what about D and L? What about D and L? The distance between D and L is 1, 2, 3, 4 units. So I will have D dash on the other side by also moving 4 units. So D dash will be 0 and 4 on the other side. Okay, what about the point C dash? Here, C, the distance between C and L is 1, 2, 3, 4 from the right side. So I will move 4 sides on the left side. I will have it C dash and it will be on the coordinates 1 and 2. The same for the point B. Here B, there is no distance or 0 distance between B and L. So B dash also will be 0 distance between the B dash and L. That's all for the reflection.